Hello everyone. Today we will explore the cooling tower software here as you can see. And in this you can see here we have two modes like evaporating condenser and evaporative cooling. So today we will learn about the evaporative condenser, and for the evaporating cooling the calculation part will be same. So let's get started. So this is the main page of the software. Here we will give the all needed inputs parameter and we will get the outputs from the software. Firstly, you can see the calculation mode. So in this we have two modes, wet or dry. So you can select as per your conditions, is it wet or dry calculation. So you can select from here. After that we have the exchanger type. So for that we have the smooth coil, spiral coil or integral coil. So you can select the type of heat exchanger from here. Now we will proceed for the project data. So firstly you can see the main section, and in this we have the geometry. So let us see the geometry part. In the geometry, these are all other geometry which are already added. If you want to add a new geometry, then please click on this plus sign. Adding new geometry, firstly we need to select the fin typology. For that we have integral, spiral and without fin. So from here you can select your desired typology. Then we need to give the fin thickness. So today I am taking 0.15. Then I'll click on next. After that we need to select the fin corrugation kind. Is it smooth, corrugated, primate, fin doped or lowered? That you can select from here. Then click on next. Now we need to select the alignment of the tube. Is it staggered or aligned? That I can select from here. After that we need to specify geometry data like tube spacing, row spacing. So tube spacing I'm taking 60 and row spacing I'm taking 30, and tube thickness I'm taking 0.35, and the tube external diameter I'm taking 16 mm. So I have taken this data for geometry data, and you can take as per your desired values. Now you can see here that I have selected the staggered alignment. So this is my row pitch. So this is horizontal distance is my row pitch, and the vertical one is my tube pitch, and this is my tube diameter. Now I'll click on next. Now let us select the tube corrugation kinds. For that we have smooth, micro fin, cross grooved and herringbone. I can select from here. Then I'll click on next. We need to give the description, means name of that geometry. So you can give any name to this geometry. I'm taking that 16, 60, 30 and test. Then click on finish. So this is how you can add a new geometry in this software. After that we have this tube and fin thickness. So you can see that tube thickness is there. This thickness I have taken. You can select the tube material from here. These all are the material which are already added in the software. But if you want, you can add a new material in this software as well. After that we have the manifold. Manifold is nothing but the header. So for the header, what is the material of the header? That you can select from here. The calculation type. So in this we have two type of calculation. First is the manual and second one is the automatic. So in the manual one, I need to define the inlet and outlet size of the header. For that, these all are the sizes which are already added in the software. You can also add a new header size in the software. Like you can see 1/2 inch, 5 by 8 inch. So you can select from here. Same thing you can also do for the outlet header. You can select the size from here. Number of couples, manifold number of couples. It means if you are putting one header on inlet and one header on outlet, that makes a couple. So accordingly you can give this number here. After that, deposition, that how you are keeping your manifold, is it horizontal or vertical, that you can select from here. Form factor, is it circular or semicircular, that you can select from here. The header length you can give here. This is all about the manual calculation. If you go for the automatic calculation, then you don't need to define the inlet and outlet header sizes. It will be calculated by the software. You just need to define the manifold couples and the deposition and form factor, and after that the length of the header. So for that I am taking 500 mm. Now this is all about the manifold. Now we will come to the split section. So split section means when the hot humid air come out from the evaporative condenser, it can create fog that falls, freeze and makes the ground slippery. So the split section solved by using a fin coil placed above the spray system, and the hot refrigerant first cool down in this coil, then reducing fog and preventing ice form that makes the floor slippery. So let us check. In that we have this, you can see this split section. First of all, if you want to active, then click on this active split section. After that, what is the coil length of that particular split section fin and tube heat exchanger that you need to give here. Number of rows, fed tubes means circuit, or if you want, you can also give the number of passes here. Now, how many number of tubes for a row means in one row, how many tubes are there, that number you can give here. After that, what is the fin pitch? You can select from this drop down, either you can give manually as well. After that, we have the tube material and thickness. This is for our main section. You can see this geometry, and this tube material and thickness is for our split section heat exchanger. So for that material, you can select from here, and you can give your thickness here for the split section. Now same way which I have told you for the main section geometry, if you want, you can add similarly as I have told you for the main section, you can add your geometry for the split section as well. The tube thickness and material I have already told you, and for the manifold for split section, you can select from here the material. Manifold, like automatic and manual calculation, you can select from here. Manual calculation, you want to go for the manual calculation or automatic calculation. I am selecting the automatic calculation here. After selecting the automatic calculation, now let's come to the fan section. So now this is the fan section. If you want to use a fan model which is already added, that you can, for that you need to tick here, and you can select the fin type, axial, monophase or tri-phase, that you can select from here. Fan builder you can select from here, which are already added in the software. Now we have the fan series. In the fan model you can select from here. Number of fans, link, you can select from here. If there is any additional pressure drop, then you can give here. And this is the graph of this particular fan model. If you want to add a new one, then just click on this fan management. For adding new fan, just click on this add option. Just leave what is the typology. It is axial, monophase or tri-phase, that you can select from here. Builder, you can select from here. If builder is not listed here, just click on this plus sign and you can give the builder name. For this, I am taking test. Series, you need to add the series for that particular one. I'm taking test 1. Now I need to give the model name as well. So I'm taking fan test model. Then click on add. You can see that fan is being added. We have added a fan builder series and model name. So let us select that one. So we have selected the new one which we have added. Now it is important to put the technical key parameters such as voltage, frequency, noise, RPM, power, current, minimum and maximum airflow, and these parameters you can easily find or get from the fan catalog. For today, I will take a sample data and let you know how to proceed with the technical data. So let me give the technical data here. Now after giving this technical parameter, additionally we need to provide the point data. So in that we need to provide on different airflow what will be the pressure, and on the basis of that software will give you the fitting curves. So I'll give the value here. So you can see here that software has given the fitting curves between pressure and airflow. So this is how you can add a new fan in this software. Now after the fan, we have the spray system. Here you need to give the spray system efficiency that you can give here, isoenthalpy efficiency that you can give here, and the quantity of the evaporative water and sprayed water will be calculated by the software. Now we have the unit data. So these unit data you need to provide here. What is the unit length, the unit height, and the unit depth. So for today I'm taking these values. After the unit data, we have the air extra pressure drop. So if you have any extra pressure drop, then you can just click on this add and give its kV factor. And for the kV factor, you can calculate from this formula and the surface area that you need to provide here. If you want to remove any element, any additional pressure drop which you have added, then just click on this remove and then click on yes. After that, we have the pump. So similarly for the pump also, as we have done in the fan section, if you want to use any model which are already added, then you can click here. And for the pump, we have the test series only. And you can also manage your pumps from the pumps management. You just click on this one. You can select your builder from here, the series. You can add the new models also. You can also give the coefficient data for that, or point data. If you want to give the point data, for the point data, you need to give the on different water flow, what will be the pressure and absorbed power. You need to give here for the point data if you want to give, or otherwise you can also give the coefficient, like on different pressure, what will be the absorbed power. And after that, you need to also give some technical parameter like voltage, frequency, absorbed power, current, minimum and maximum water flow also. On the basis of that, software will give you the fitting curves. After that, just click on save. So this is how you can add a new model, a pump model in this software. The main project data. So here you can see we have two sides, air side and fluid side. So firstly, we have the capacity. Capacity will be calculated by the software on the basis of our input parameter. You can, for the capacity, you can select the desired unit from here. BTU per hour, tons refrigeration, kilowatt, watt, that you can select from here. After that, we have two sides, air side and the fluid side. In the air side, first thing is the airflow from the fan balance. So you can give your airflow here. If you want to give the phase velocity, then select the phase velocity. You can give here. If you give the airflow, then the phase velocity will be calculated by the software, or vice versa. So today we will go with the airflow. You can give the airflow. After that, we can give the atmospheric pressure here. Or you can also go with the altitude as well. Generally, people go with the atmospheric pressure. So you can give here. After that, we have the inlet dry bulb temperature that you can give here, the air temperature. Inlet wet bulb temperature of the air that you can give here. If you don't know about the inlet wet bulb temperature, you can also go with the relative humidity. You can give the relative humidity, or we can say RH value, or specific humidity value also. If you give any one of these three values, another two will be calculated by the software. Now, outlet dry bulb temperature will be calculated by the software, like wet bulb temperature and RH will be also calculated by the software. Now we have the fouling factor. Fouling factor is nothing but these, sometimes over the tubes there is some unwanted particle like dust, mist. These kind of particles cover the tube's upper part. This becomes the resistance for the heat transfer, or we can say the capacity. So if you have that value, you can give here. After that, we have the pressure drop. Pressure drop of the air side will be also calculated by the software. Now we will come to the fluid side. So for the fluid side, first of all, we have the fluid, which fluid we are going to use, that you can select from here. So we have a wide archive for the fluid, or refrigerant we can say. So you can see here, you can select desired one from here. Or you can also add a new fluid in this software. After that, you need to give the evaporating and condensing temperature here. If you are doing any subcooling or de-overheating, that value you can give here. Fluid flow will be calculated by the software. The pressure drop of the fluid side will be also calculated by the software. Fouling factor, same as I have told you for the air side. If you have the value, then you can give it. Fluid velocity will be calculated by the software. Now we will come to the physical data of the fin and tube heat exchanger for the main section. Firstly, you need to give the number of tubes in one row. How many tubes are there in one row? If you don't know about that, you can also go with the coil height. You can give the coil height value or length height ratio of the coil. Now, number of rows. How many number of rows are there? You can give here. The coil length, you can give here. Fat tubes means number of circuit, you can give here. Or if you don't know about that, you can also go with the passes number. Now, we have this option, consider bands in the exchanger surface. You want that software should consider the bands also in the surface area, then you can tick it. Otherwise, you can, if you don't want, then you just untick this option. After giving all these data, just calculate button. So these all are the values which is calculated by the software. You can also have the printout sheet for this one. Just click on this print option. You can see report is being generated. So you can see there are firstly two boxes are there. In first one you can put your company logo, and the second one you can give your company details like company name, address, phone number, fax, email. Now in the very first section we have the customer name. You can set your customer name, your references, date and description as well. So this is our evaporating condenser. This is the details of that geometry with geometry. Calculation mode is VAT. Now the geometry is there. How many number of tubes per row we have taken, number of rows, coil length, number of circuit, number of passes, the results which are capacity and surface area. After that we have all the inlet and outlet condition of the air side, like you can see here, volumetric airflow, mass airflow, phase velocity on the coil, inlet air density, inlet temperature, RH of the inlet air, outlet condition also there, like outlet air temperature, outlet RH, pressure drop, and fouling factor we have taken 0. If you have the value you can take, then that value will be reflect here. Then we have the fluid side, what fluid we have taken, what is our evaporating and condensing temperature, and the subcooling and de-overheating, the enthalpy of different conditions like superheated steam, saturated liquid, subcooled steam also, and the total pressure drop of the fluid side will be there. In the geometrical data like what number of rows, coil length, number of circuit, tube material, tube external diameter, manifold, like what is the inlet outlet size of the manifold, which is calculated by the software, what material and the length we have taken, what is the form factor, everything will be there related to the manifold. Now after the data we have next our psychrometric chart printout will be also there. Same condition which I have shown you in the graph. And on the last page we have this unit drawing. So as you can see, this is our unit drawing. These are the unit dimensions and this is the geometry, and this drawing will be always like the same. And you can also export this sheet in the PDF. Just for that, just click on this PDF option. Now you can save this sheet in your desired location. Just click on save. So this is all about the calculation part of the software. With the software you can design your evaporative condenser. I hope that this video will be helpful for you. Thank you so much for watching this video.